Hello, welcome to Maths with EJD. In this video, I'll be solving a structured problem that is in three parts. And the first question is to conceptualize the term statistics. Secondly, write a short note on the following terms: descriptive statistics, inferential statistics, parametric test, non-parametric test, parameter, class limit, class mark, and class boundary. And lastly, draw a pie chart for the data in the table below. Profession and salary per year: teaching 1,200,000, engineering 8,600,000, accounting 7,980,000, and consulting 3,200,000. So let's get to work. The first one is to conceptualize the term statistics. So that is the A part of the question. And straight to the point, statistics is a branch of mathematics that deals with the collection, organization, analysis, interpretation, and presentation of numerical data. Okay. You can actually continue to say it involves methods for summarizing data in ways that highlight patterns or trends, and for making inferences about a population based on a sample. Then you can now talk about the application. It plays a crucial role, in various fields such as education, business, science, health, and social sciences to support decision making and research. So that way we have conceptualized the idea of statistics, we have conceptualized statistics. So that's the first part. The second part says, write a short note on the following terms, 8 terms in all. So let's take them one after the other. So that's the B part now with 8 subparts. The first one is descriptive statistics. Descriptive statistics. Okay. So this refers to statistical techniques used to summarize or describe a set of data. It includes measures such as mean, median, mode, standard deviation, and range, as well as graphical representations like histograms, pie charts, and bar charts. The primary goal is to present data in a meaningful way. To reveal trends or patterns. Okay, that's about descriptive statistics. Then we have number two. Number two is about inferential statistics. Inferential statistics. Inferential statistics. So, there are two types of statistics, descriptive statistics and inferential statistics. So I've just talked about descriptive statistics. For inferential statistics, this involves methods that allow conclusions or predictions to be drawn about a, a population, about a population based on a sample from that population. It uses techniques such as hypothesis testing, confidence intervals, and regression analysis to make generalizations and assess relationships or differences between groups. Okay, so that's about inferential statistics. Let's take the third one. The third one is parametric tests. So a parametric test is a type of inferential statistical test that assumes the data follows a certain distribution. Typically, the normal distribution. Examples include t-tests and ANOVA. Normally, I was supposed to go to ANOVA next. So the next video I'll be making on statistics is about ANOVA. That is analysis of variance. Parametric tests are usually more powerful than non-parametric tests when the assumptions about the data are met. Okay, so that's about parametric tests. And we go for the fourth one, non-parametric tests. So these tests do not assume a specific distribution for the data and are used when parametric tests assumptions are not met. For instance, if you don't know the particular distribution the data you have follows, so you may want to use non-parametric. So examples include the Mann-Whitney U test. I have a video on this in the statistics playlist. You can check that out. Mann-Whitney U test and the Kruskal-Wallis test. They are useful for data that are ordinal, skewed, or do not meet or do not meet the requirements for parametric testing. And then we go ahead to talk about parameter. What is a parameter? That's the fifth thing. Parameter. Now we've talked about parametric, non-parametric. So what is that parameter? A parameter is a numerical characteristic of a population, such as the population mean, say mu, or population standard deviation. That is sigma. So it is a fixed value that describes some aspect of the population. Okay, so we get to talk about test statistics and test parameters and test statistics. Parameters belong to the population, while the statistics belong to the samples. So for population, we have population mean. For population, we have population standard deviation. But for statistic, we have statistic for samples, we have statistics like sample mean and sample error, or samples, or we have error, standard error, or sample standard deviation, something like that. Okay, that's number 5 right there. Number 6, this sixth thing we have to write about is class limit. Class limit. Data can be grouped into classes. So that's talking about grouped frequency now. In a grouped frequency, okay, in a grouped frequency distribution, rather, in a grouped frequency distribution, the class limits are the smallest and largest values that can be included in a class. For example, if a class is defined as 10 to 19, the lower class limit is 10 and the upper class limit is 19. So that's the idea of class limit. And we go to the 7th thing we want to talk about, which is class mark. Class mark. The class mark is the midpoint of a class interval. It is calculated by averaging the lower and upper class limits. For example, if the class interval is 10 to 19, the class mark is 10 plus 19 divided by 2, that is 29, divided by 2, and that is 14.5. Okay, so that is that. Then we have the last thing we want to write about, that's number 8. Is the 8th thing. Okay, that was 6. So this should be, actually, this is 7. Then the 8th thing we need to write about is class boundary. Okay, so here, class boundaries are values that separate class boundaries are values that separate consecutive classes in a grouped frequency distribution. They help in avoiding gaps between classes. For example, if the class intervals are 10 to 19 and 20 to 29. The class boundary between these two would be 19 plus 20 divided by 2. You know, that's the top of this class and the low of this class, the upper class limit of this class and the lower class limit of the other class added together divided by 2. That's 39 divided by 2. That is 19.5. So this 19.5 now is the class boundary. It's a class boundary between the two classes. So we can do that for subsequent classes too. Okay, so we are done with the B part of the question. Then let's go to question C, which involves drawing a pie chart with a given kind of data. Let me refer you to the question again in the beginning. So this is draw a pie chart for the data in the table below. Profession, salary per year. We have teaching, engineering, accounting, consulting, and their corresponding salaries. So we need to draw a pie chart for that. So I'll just try to do the table again. So we have profession, we have salary per year. Okay. So first we have teaching. I wonder why teaching is the lowest. That's so not correct. So that's 1,200,000. Maybe that's some activism I'm doing right there. So teaching, then we have engineering. Engineering is 8,600,000. And some people will argue that the other professions would not exist without teachers. So why do teachers end the list? Then accounting. Accounting is 7,980,000. Then we have consulting. Consulting is 3,200,000. Okay. So I think the first step towards drawing the pie chart will be to find the total. Let me go this way now. So the first step will be to find the total of all this. And the total in this case is, let's see, 15 plus 2, 17. Is it? 15? Okay, yeah. 2 plus, we have all the zeros are gone. So we surely have 3 zeros. We have 80 here. All these zeros settled already. All these zeros done. Then we have 8 is the only one there. So 2 plus 6, 8 plus 9, 17 plus 2, 19. That's 9. We have 1 left. Then 1 plus 1, 2, 10, 17 plus 2, 20. So is it that? 8 plus 1, 9, 9 plus 7, 16, 16 plus 3, 19. What's happening here? 2 plus 6 is 8. 8 plus 9 is 17. 17 plus 2 is 19. Yeah? 19. Then we have 9 plus 7, 16. 16 plus 3, 19. 19 plus 1 is 20. Or am I getting something wrong here? We have to see to that. 1,200,000, 8,600,000, 7,980,000, and 3,200,000. So hope I'm not making a mistake. All three zeros, zero there. 8 is next. 2 plus 9 is 11. 11 plus 6, 17 plus 2, 19. We have that 9. So we carry 1. 1 plus 1, 2 plus 8, 10. 17. plus 3. This is 20. This should be 20, right? That should actually be 20,980,000. Okay, let me check. Okay, 20,080,000. Um, the total salary. This is I think there's a contradiction somewhere. I want to be very sure. 1,200,000, 8,600,000, 7,980,000, 3,200,000. So all the zeros done. Zeros here, 8 here, then 11 plus 6, 17 plus 2, 19. We hold 1. Then we have 9 plus 7, 16 plus 3, 19 plus the one we're bringing, that's 20. 20. Yes, I need to get to the root of this. I want to be very sure. Um, because from other places I'm getting something not 20. Let me be very sure of this before we proceed. Um, I don't have my calculator here, that's why I'm having that issue. But I feel that what I've done with what I'm just do that mental sum I'm doing, I think it should be fine. But we need to be very sure, very, very sure that is okay. Um, teaching. Normally, this shouldn't be this difficult. One million 200,600. Okay, 8,600,000. 8,600,000. Then 7,980,000. 3,200,000. Yeah, this is 20,980. 20,980,000. Yeah, I'm correct. Okay, so with this now, we have confidence to talk about the charts. But to calculate a pie chart, right? A pie chart is simply dividing a circle into into proportions corresponding with the percentages that each of the professions would occupy. That is exactly what the idea of a pie chart is. So the first thing we want to do before we start thinking of calculating the pie chart would be get the to get the percentages. Okay. So the total is 20,980,000. That's what the total is. So the total is 20,280,000. So we have to get the computation right. Okay. So um to find to find the to find the angles. Okay. Are we told to calculate the percentages? Let me be sure of that first because I know the angle is what we need on the circle. Draw a pie chart for the data. We can then calculate the percentages. Okay, so it means we are going to do percentages and the sector on this on the chart. So to find the percentages, to find the percentage, stroke and angle. Let me see percentage and angle of the sector for each profession. So, for the so talk first of all, we start with teaching. So let's go teaching. So for teaching now, we have teaching is 1,200,000. So 1,200,000 divided by the total 20,980,000 times 100%. We'll get the answer there. And correspondingly, we will get 1,200,000 all over 20,980,000 980,000 times 360 degrees. The reason for this is, if you have a circle, right, the total angle is 360 degrees. So you're going to get the angle on the sector corresponding to what exactly you have here. So I'm just going to write this out first, then I'll do the calculations later. So I can be very sure everything is in order. So the next thing is engineering, right? Engineering. So we have for engineering now. So for engineering, we have 8,600,000, 8,600,000 divided by 20,980,000 times 100%, Then for the angle, right? For the angle, we have same thing, 8,600,000 divided by 20,980,000 times 360 degrees. That will give us the angle for the sector. Then we have accounting. Accounting is 7,980,000. 7,980,000 divided by 20,980,000 times 100%. That gives you that. And then for the angle, in fact, the angle is going to be whatever percentage of that times the sector times 360. That's also good. So you have 7,980,000 divided by 20,980,000 times 360 degrees. This will give us the angle for the sector. Then lastly, we have consulting, which is 3,200,000. So consulting, 3,200,000 divided by 20,980,000 divided by 20,980,000 times 100%. Then we also need the angle to draw so we need the angle. That will also be 3,200,000 divided by 20,980,000 times 360 degrees. Okay, so we have set out all this. So let's get the values out. So first of all, let's get the values. All right. So we have 1,200,000 divided by 20,980,000. Okay. So that is 0.05, 0.057. Let's just take it to times 100%, right? That is 5.7%. Okay. Well, multiply by 100, that's just 5.7%. So the next one, we have 1,200,000 and okay, of course, times 100, right? Then now times 360 degrees times 360. So that will give us the angle of the sector. So the angle here will be 20 million, 20 million. Oh, not 20 million. That'll be 20.6 degrees, sorry, 20.60 degrees. So because we need, this is what we need to really draw the angle on the circle, the portion teaching is going to occupy on the circle. Okay. Then we have 8,600,000. That is 8,600,000. Yes. So and that will be 8,600,000. Okay. First of all, times 100, right? Times 100. We have that is 0.41 times 100%. Okay, let me color code here. Let me color code 0.41 times 100%. And that will be 41%. Okay. And then, of course, if you want to calculate the angle, right, you multiply that by 360. So you get everything goes to 147.6 degrees. Then here, so you can use the percentage or the angle to draw. Okay, but I think percentage may be more efficient. So 7,980, right? We have 7,980,000. Okay, so first, that is going to be 38. This is 0.38, 0.0 times 100%. So that is 38%. And for the angle, right, that's times 360. So that will be 137, more like 136.9 degrees. Then for this one, we have 3,200,000, 3,200,000. Yes, over 20,980,000. So that is 0.15. I mean, 0.153 times 100%. So that is 15.3%. And for the angle, that's times 360 degrees. So that is 54.9 degrees. So if you want degree or percent, you can use either to plot. Okay, so normally, right, you can go in proportion to the angles you have. So you can see that engineering carries the largest share, which of 41%, followed by accounting 38%, followed by consulting 15.3%, followed by teaching 5.7%. But to get a very accurate pie chart now, I'm going to switch to Python because I know it will do a more accurate job than what my hand can do. Normally, in an exam situation, you need to draw a circle using, I think, a set square. And once you do that, then you draw a line. Then from that line, you can now begin to draw the angles, you know. So, but using a pie chart, you can be sure. I mean, using Python, you can be sure it's going to be better. I mean, you're going to get something more accurate, but in the exam situation, you have to do what you have to do, right? So here I'm using matplotlib to do that. So we need matplotlib for data visualization. Then for the pie chart, and we have the professions, teaching, English, engineering, accounting, and consulting. The salaries, we also have them. Then total salary is the sum of all the salary because we need that to calculate the percentages, right? So we are now calculating the percentages here. So we say percentages is salary over total salary times 100 for salary in salaries. That is, you are running over the salaries to draw this out. So if you want to get the percentages, then we can actually print the percentages. We print the percentages. So, uh, and then this here is to show the plots with their different angles. So if I run this now, it gives us the percentage. So you can see 5.71 like we first got, 40.9, which is like 41. This is 38.0, and this is 15.3. And this is what it looks like. So the biggest goes to engineering, 41%. Accounting follows with 38%. Consulting is third with 15.3. And that's how that would be. So you can see how that goes. Okay. So with that, we come to the end of this particular question. Thanks for being here. If you have not subscribed to this channel, be sure to do that. Hit the notification bell also so you can get alerted each time a new video is released. And don't forget to like, also comment. Like this one, for instance, is a request from someone to help solve this. And then you can also share so that more people can have access to these things. Of course, this question continues in the next video, so watch out. See you next time. Bye.